battery go no go for a EV vehicle is the state of health. The SOH gives a final definition, and in principle it has been agreed as an industry standard that at 80% SOH you should start looking at repurposing the battery. Now repurpose we already discussed, I am not going to rename it. This can go to data centers, they are mushrooming up big way. Example, static applications. Static application, that's where your charging and discharging rates are not as high as as you see in the automotive vehicles, because torque requirement and motor loads are different. Therefore, in a static application, you can go up to 0.3 to 0.5 charge levels. At that level, the battery SOH and the requirements of the battery, because you don't then, okay, in static application, you also don't do so many charge discharge every day, every year. For example, if I'm running a bus, so if I have to run it non-stop and even if take 1 week of sort of off time, which is we call for repair, maintenance, PM. So coming back, these batteries, as we have seen in last 4 years of our deployment, we are seeing very interesting things. We have seen both experiences on LFP and MC, and it's again discovery going on. We all are learning. So the way what we are doing as an organization, we have got some of the batteries written from Mumbai area. Now during COVID, what had happened? Most of the batteries, they were dud. They were not running for many months. The natural chemistry is always alive, like human being. Battery अपनी natural discharge होती रही. The electrochemistry doesn't stop. It kept on doing something, and the value went down. So we have now taken a call, and we are creating a repurposed battery stack. We are creating in a modularity form, 100 kilowatt, 200 kilowatt, and 300 kilowatt types. But they will all be modular in nature. The reason is, and that's where I think we need some sort of quick project work on this, and I can very see the BMS and Panigrahi, your team. The way BMS is programmed for a vehicle is not the way the BMS will be programmed for a BS application. Now that is a problem. The moment you pick up, it's not like I pick up a battery from bazaar and start putting some electrical wires and it'll work. It will work, but then you need protocols. So they have to be, now you cannot create a software agnostic protocol. The algorithms are very important. मैं core की बात कर रहा हूँ. So I think we'll have to come with some unique solution. And Dr. Panigrahi, we have to think over this. That even if we create a recycle bank, and there's a repository, I call it battery bank. So this battery bank actually takes so this is a repository. Everybody goes and puts their batteries there. But how do they operate? Because there is no common software. Tata Power, also Tata Motors will be different. MG Hector, they have got their own BMS, your own LECUs, and then so and so forth. And so it's for us also. NMC, LFP, and LTO, again different protocols. And every vehicle or every battery stack has got its own protocol. So there are going to be at least, as or now in my organization, I'm staring at 24 BMS algorithms running around in 24 different type of battery packs. So you please understand. So this is so it's not कि करना नहीं चाहेंगे, बिल्कुल करेंगे. So we need to address this problem, Dr. Panigrahi, and I'm personally struggling on this. I have been telling that okay, today it's 11 protocols. In next 3 years, we are going to hit 50.
Thanks you.
So that's what
Arunji, thanks a lot for opening the eye. That's why Saurabh is here. I have invited him today. Although, Dr. Saurabh is a faculty at CART Center for Automotive Research. He has vast experience in the battery management system and all other things. And we look forward for all these things. If Saurabh, you can tell for a minute or something, and then we will close.
Yeah. So I think that's a very good point raised by Mr. Kapoor, because when we have all these battery packs retiring from different applications, or even let's say we are just collecting the battery packs from different cars, just four-wheelers, they have like different chemistries, and these batteries are degrading at a very different rates, even within a pack. So how do we combine them and repurpose them together for another application? So I think that's where we'll have to set up some standards that, okay, this is how we combine and how do we qualify it? Because if we don't do it, then people will just come up combining multiple packs, putting it together somewhere, and as we know, lithium-ion batteries are quite unsafe batteries, so that can lead to a lot of problems later on. So I think some kind of a standard protocols or for repurposing and reusing is also necessary and something has to be worked
No,
on.
thank you. This is something which is very close to my heart also, which is why I was insisting. And sir, thank you so much for your, inputs. We will work with you after this event to see how we can take these things forward. Any last comments? Yes, sir.
Yeah. I think we can talk a little about the recycling of these LIVs. Yeah. In our country, we have two types of battery. Right now, majority of our batteries are lead acid batteries. 98% of the recycling of the batteries is happening in lead acid batteries. And we have a very good, huge ecosystem. We are nearly 600 recyclers. And they are in lead acid batteries, most of the recoverable thing is a lead. So by 70% by weight and 95% of the lead is recovered. It's not issues there, but there are certain compliance issues with respect to pollution potential and battery braking units and the effluent treatment. This is regulated by the state pollution control boards. Coming to the LIBs, there are not many in the country, but the issue is not about the technology. Technology is also available. What we are seeing that about 14 facilities are in pipeline. They are concerned to establish, they got it. What is that the ecosystem of battery recycling is directly linked to the availability of batteries. If you look at every one of them are looking for they are always starving for the used batteries, end of life waste batteries. So right now they are doing most of their volumes from the EEE, electrical and electronic equipment. So mobile batteries, these batteries are coming. But e-mobility batteries are still not coming. So some of the, even you don't have the manufacturing units in the country that are still coming. So there is at the time of reject batteries, there are some volumes. This is one issue, and one issue we are facing is that recovery of molecules, compounds from the LIBs. Again, themselves, cobalt is one is the driving factor for LIB recycling, cobalt salt. From there, the lithium salt is of no use. So there is no value. If you try to recover, it is a negative cost for recycling. So right now, it is driven by nickel, cobalt, copper. These are the primary materials. They are sustainable on that. One of the major problem in pollution point of view we are facing is that there are there are two components. In the first phase of the recycling of LIBs, one is the black mass. Black mass is the stage that comes separation of the cathode material from this conducting just aluminum, copper sheets and aluminum sheets. Thereafter, the processing is highly complex and patented technologies. There is solvent extraction, other hydrometallurgical processes are involved. So what we are seeing is that some of the black mass is getting exported because right now it can be done in India, people are there to invest, but volumes are not there. So this is one area we are closely watching. But the safe separation of black mass from the thing is one area is also challenging, the pollution perspective. So we are regulating environment, so our focus is on environmentally safe recycling of LIBs and lead acid batteries. So this is how, and we are seeing that since the life of the battery is more than 8 to 9 years of lithium, and in the coming 5 to 6 years, this is the market is going to increase. So right now CPCB working on development of environmentally safe standards, guidelines for recycling. So we are working on the standards development. Thank you.
For this point, sir. And, a couple of days ago, I was with Dr. Jayachandran. I think he will be joining later in the day. We have solid waste management session lined up in the second half as well. And there's an eco park coming up in Delhi, around Narela or somewhere. And some of our solutions that we develop will be installed there. And very rightly said, the value chain needs to be developed for sourcing the batteries. And at least, we have some majors sitting here with whom we can work together and develop that value chain. So point very, very well noted, very important. One last comment, and then we close this session. We've already run out of time. Okay, I think there are no final comments. So thank you so much for your inputs, and be rest assured that we will be working with your inputs, defining some projects, preparing a summary of this discussion, and circulating it and sharing it with all of you. Please just allow us some time because, we are entering into the middle of December now, and holiday sessions, are coming up. My team has already planned their break. So you will be hearing from us us towards the end of the year, or more likely, if I'm honest, towards the beginning of January in the new year. And we will be working with most of you in terms of constructing projects and taking it forward. Now, in terms of logistics, we break for coffee now, and we will be back. Let me see what time it is. So earlier we had scheduled half an hour tea break. But because we have run over time, if we can take a short 15-minute bio break and tea break and come back, please, to discuss the air pollution mitigation problem. Thank you so much.
Vipra.